Just somewhere you found to kind of like, okay. Did I assign it? I'm guessing I assigned a problem. Can you guys tell me which one? So I kind of know what the point of the problem was. Because I could just give you, no, real quick.
Give us a maximum profit question?
Did I?
No. Well, I don't know.
All right.
Saying, you wanna make one up?
So real quick. Let me make sure this is understood. If I give you a function, let's say I give you watermelon yield per the amount of fertilizer, yeah? And I tell you the watermelon yield per the amount of fertilizer is negative 0.03 fertilizer squared plus 8 fertilizer minus 1. It doesn't matter. It really doesn't matter. That was nifty. You guys all with me? It doesn't matter what the function is that I give you. In fact, this is related to the question we had upstairs about the agriculture problem. Remember? I could give you a function from quantum mechanics. Do you have to understand quantum mechanics? No, because the understanding of quantum mechanics put that function together. Do we have to understand agricultural watermelons and the effects of fertilizer? Because that went into creating this. Now I'm going to ask you, how much fertilizer, it's a very interesting morning, how much fertilizer will maximize my watermelon crop? What would you do?
Find a derivative.
Find a derivative. So if I give you the function and I say maximize that, you're like, oh, thank God, Jeff. Holy shit. You just did the hardest part of the problem for me. Thank you. Because what's the hardest part of any optimization problem? Setting the function up. After that, it has to be easy as shit. You just take derivatives, find the critical numbers. Are you guys kind of with me? Okay. So here I would just take the derivative. Set it equal to 0, solve it, blah, blah, blah. Right? Is that all right? So yeah, if I give you a problem and I say, here's the function for whatever, find the max or min that, you're like, sweet. I can just start doing calculus right away. It's already set up for me. Yeah.
I guess I'm struggling between like min and max, like what the steps are, because I can figure out the min derivative, set it to 0, and then I know max has like an extra step.
No. Okay.
Or is it the same
No.
thing? Am I getting it?
The process you just defined is finding critical numbers, correct?
Right. And then you go-
What are critical numbers? What are they? Don't tell me it's where the derivative is 0 or undefined. Yes, that's how you find them. What are they? The possible locations of maxes or mins.
Right.
So the amount of work for either is exactly the same.
Okay.
The extra step would be actually making sure that it's a max or a min. So for example, you try to maximize profit function, and you tell your boss, oh yeah, we got to make 15,000, and actually that was a min.
Right.
That's not going to be good. So you got to make sure the thing you found was an actual max if you want a max.
So you have to take the second derivative?
You could do the second derivative, yeah. You could do the first derivative test, make a sign diagram, make sure if it's a min, it's going down and then coming up, right? Is that all right? Yes.
If you get the min but you want the max, what do you do?
Do it again, sir.
Or like if you take the derivative and it ends up being the minimum, but you make the maximum, what do you do about that?
It's the same thing, isn't it?
So
Is that
I think it's just different words, but.
if they give me, if I get multiple critical numbers, then you got to make sure you get the one that's the actual answer. One might be a min. Very often, for example, on rectangle problems, you'll get two critical numbers. One will be 0, and the other one will be some number. If x is 0, what's the area? That's a minimum. So in general, when you do any optimization problem in the universe, you could get multiple critical numbers. Any of them could be a min or max. So then you have to test each one to make sure you get the one that's the right thing. Do you want to minimize it? Do you want to maximize it? Yeah. Most of our problems, you get one critical number that makes sense, and that's the answer. But you still need to actually verify it's a max or a min. Okay. Yeah, remember? Yes?
I found.
Found what? The store has been selling PlayStations. Oh!
Is that the motion?
I don't know. Did I assign one like this? I mean, this is a very specific kind of problem, that's more if we're business calculus class.
There's one
Uh,
at 67. maybe?
Good, alright, good, so I did assign one, so I'll do. Number 67,
Yeah, I think that's kind of what you're looking at, but.
yeah, sweet, okay, good. This is the same problem as that problem. Okay. Read through this real quick, 67. So did I assign 67? Anybody? No? I love you guys so much. So real quick, just to satisfy some curiosity. This is interesting because this is kind of close to what we do in real life.
We did like 62, but.
Oh, that's completely not like this. Okay. So baseball team, it seats 55,000 people. Does it make sense that if I raise the ticket price too much, I'm not going to get as many people coming in? And if I lower it too much, I'll fill the stadium and I won't make enough profit. You guys agree with me? Inherently from that understanding, do you all agree that there should be a sweet spot? Where I set it just enough so maybe I don't fill the stadium, but the people that come are paying enough that I make a profit, a good profit, the best profit. You guys all with me? So that's what financial analysts are doing. They're always chasing the best profit. Is everybody with me so far? Okay. When they set the ticket price to be $10, the average attendance is 27,000. So what's their average revenue? Yeah, 27,000 times 10, so $270,000. You guys with me? That's their average. So they're like, can we make it better? If they lower the price, more people would come. More people could afford it, but they're losing revenue per person, but maybe enough people come that they still make more money. Or if they raise the price, less people come, but each one of them is paying more, maybe that'll make the profit go up. So the question is, should I lower the price? Should I increase the price? Or should I keep it the same? Are we already at the sweet spot? You all agree with me that we're not anywhere near filling that stadium at the moment? Okay, so it seems like maybe more bodies would be good, but let's see. When ticket prices were lowered to $8, the average attendance rose to 32,000. Okay, so let me say this. What's the question in this problem? Don't worry about part A, screw the part A. How should ticket prices be set to maximize the revenue? So really the question is, how much should we change the ticket price to make the revenue maximum? You guys all with me? You guys with me? A big part of every one of these problems is translating from author speak to freaking English.
It's not asking for what the price should be.
It is.
Is it changing the prices?
Those are, you said the same thing twice. If I said raise the price by $1, doesn't that tell you what the price should be? So if I know how much I should change it by, that tells me what the price should be, yes? Okay. The reason, so assuming this is linear, every time I lower the ticket price by $2, how much does the attendance change?
6,000.
By 6,000. So if I lower the ticket price by $4, I would expect this to go up to 39,000, yes? I would expect it to go up by 12,000, yes? Is everybody with me? That is a huge assumption, by the way, but let's make it. So, yeah, when ticket prices are $10, let me just put P for price. When the price is $10, the attendance is, what did it say, 27,000? If I lower the ticket price by $2, let's do this. What's my variable gonna be? Based on how I try to couch this problem. What's my variable gonna be? What could I decide to do? No, variable's not ticket price.
Changing price.
Thanks. If anybody comes late, they can just figure out which store works. Do it again, sorry.
changing price over changing tickets.
No.
The profit.
They said, what did they do? If they changed it to $8, the attendance went up, correct? Say again?
Change the attendance over change the price.
No.
Profit.
I'm just telling you, the variable's gonna be the amount that it changed the price by. Isn't that what makes things happen? What do we decide to do? We decide to change the price, and then shit happens, yes? So isn't that like, that's the input, our change in price? And then we see what the output is, how the audience changes? You guys see that? The nice thing about this specific problem is these kind of problems you always do the same way. So watch this. If I choose to say X is the change in ticket price. And by the way, real quick, right now, their profit was this, yes? In fact, why does that make sense, their profit is that? Because I would just take the price per ticket times the number of tickets. Of course I would, yeah? That's their revenue. I really hope that doesn't keep going.
Missed the zero.
Oh yeah, I missed this thing. So, what will the ticket price become if I lower it by this much? 10 minus 6. And what happens to the audience?
7,000.
Every time I lower it by an amount, and actually let's be more specific, let's do exactly what they did. Then I lower it by $2. And how much did the audience go up? It was 6,000, yes? Okay. So then what would the revenue be now? How do I always figure out, how many tickets would I sell in this scenario?
You sell for X from the price.
No, how many tickets would I sell in this scenario?
It's,
How many tickets would I sell?
price eight.
27,000 plus 6,000 X, yes? And how much would they each cost? 10 minus 2X. So how do I figure out the revenue? How did we figure out the revenue here? And what makes sense? If I sell this many tickets and they're each this much money, don't I multiply? So I sold this many tickets and they're each this much money, yeah? So I multiply that, and that would be the revenue function. I would take its derivative, set it equals 0. Yeah. Okay. I don't want to spend too much time on it because I didn't assign one like this, but so every single optimization problem wants the same thing for you. You create the function you're trying to optimize, maximize or minimize, and then do calculus to it, right? That first step, though, has so many steps in it because it depends on the situation. Is it the closeness of 2 points? Is it trying to minimize the surface area of a barn? Is it, holy shit, could be anything. Okay. But just because you were desperately curious about that, I just want to talk about it for a second. Okay, anything else before we do this quiz? It's already 10:30. Yes?
There's an inscription question on 32.
Yeah, okay, good. This is the kind of question I expect questions about. Okay. 32. A bad feeling that sounds is going to keep going. Largest trapezoid inscribed in a circle of radius 1 whose base is the diameter of the circle. Okay. So the drawing a picture here is, if you don't, you're insane. I mean, that's the bottom line. You desperately got to draw this damn picture, yeah? Can everybody envision this? Can you all see a trapezoid in your mind right now? Okay. I understand there are people that can't imagine things. You guys know that? I feel bad for them, but I don't know if you're one of those people. I'm sorry. There it is. Look at that. Okay. So if you need to, you can draw it in front of you. Yeah. Okay. Can you see now a circle? So get a circle. Draw on a diameter. Right? Circle's not amused. Now, the next question is, what the hell does inscribed mean? It lives inside that shape. So I could have a trapezoid with a circle inscribed, right? That would be, but here I have a circle with a trapezoid inscribed. So what inscribed means is every one of its little points has to hit, Jeff, you can do it, buddy, has to hit the circle. So that's inscribed. So if I had a circle inscribed in a triangle, it would look like that. Triangle like that. It must hit the sides. That's what inscribed means. Circumscribed means you go around it. That's what like Magellan did, for example. Little history class. Okay, this is a horrible picture, but that's okay. He draw it again. I can't say that. Bless you. Think. That's much better. Okay. Is everybody with me? That's inscribed trapezoid. Its base is the diameter. And it wants to find the largest area. And of course, this radius is 1. So what's this base here? 2. Now, so here's the issue. I need to know what the height is. Because what's the area formula for a trapezoid again? And if you forgot, you just look at the front of the book.
1/2
Yes, 1/2.
plus base 2.
Sum of the bases. Height. So a triangle is 1/2 base times height. A trapezoid has 2 bases, so they just both get to be in the equation. Okay. So the trick with this problem is, this is a circle of radius 1. Let me give you the tools you need to be able to do this problem. Does anyone remember the formula? Because every single one of these points, what's true about them? Every point that I just say it, they are on the circle. So they must satisfy the equation of the circle, correct? If a point lies on a function, it must satisfy the function. Does that make sense? What's the equation of the circle? I hear people telling me circumference, area. You're not giving me the equation of the circle.
I equals M equals B.
X squared plus y squared equals 1.
That is a straight line.
X squared plus y squared equals
X squared plus y squared equals 1. In general, it's r squared, but the r here is 1. Does that look familiar to everybody? X squared plus y squared equals 1. That's where like sine squared plus cosine squared equals 1 comes from, right? Sine is the y piece, cosine is the x piece. So of course they add it to be 1 least squared. So every point that's on this trapezoid must work in this equation. That will help you. Another thing to realize is I need to know this base length, correct? All right. Can somebody tell me what this point is right here? What that point is right there? You cannot tell me numbers.
X, Y.
Okay, XY. Good start. XY. Which means what's this? That's X. Cool, right? If that's XY, that's X. And this, of course, is Y. That's crazy.
5/3.
So how tall is this trapezoid?
Y.
Y. I love it. All right, let me stop for a minute. So everything started by me drawing the picture. I know you're not used to the word inscribed, but there's examples that show you what inscribed means. To be inscribed, it forces it to look like this. Now, couldn't I have drawn like a very squat trapezoid?
Yes.
That's why we're trying to figure out the sweet spot. We're trying to figure out exactly where should I put this so that the area is the biggest. There's a sweet spot somewhere. Maybe. What else do I want to tell you? So right now, what would I put here?
Y.
Good. I would put Y. What would I put here? 2.
X.
And what would I put, how big is this base? If that's X, what's this?
Squared.
It's negative X. So how long is this?
0.
2X. I love you guys so much. How long is this? How far from here to here? X. How far from here to here? How far? X. So how long is this? 2X. Okay, so again, what is motivating me to figure out the stuff I just figured out? This is the formula that I'm trying to maximize, yes? And then I just say, okay, what does that formula need from me? It needs to know the height. Height's y. Which is a little unsatisfactory, but it's true. The way we draw it, the height is y. What's 1 base is 2. That kicks ass. Thank you. Thank you, base 1. You are the real MVP. The top base sucks at first. Until you realize, oh yeah, this is just x, y, so this must be x, and this must be x. That's 2x. So now you know base 1, you know base 2, and you know the height, sort of, right? So what sucks? All right, somebody help me out. Let's see if you guys can help me out. When I put everything we just figured out into this equation, 1/2, what goes here? 2
Plus 2x
plus 2x.
times y.
Now, can somebody identify what is wrong with that equation? Why don't I want to start taking derivatives? Number of variables too damn high, yes. Okay. What relationship have we not used yet that was pointed out earlier? XY must live on the circle, and there's the equation of the circle. This is what they tell me. This is what they ask me. Can you use what they tell me in what they ask me? Yeah. It's not going to be pretty, by the way. Because you're going to have to take a square root to solve for x or y. Your choice. If I were you, I'd solve for x. I'm sorry. Yes, no, I'd solve for y. That'd make this step a little easier, I think. Okay, enough. I don't know if anybody started that problem, tried to do that problem. Okay. Does that help at all? Anyone get this far and didn't know what to do next? I don't know. Once you solve this for y and plug it in, then you want to take a derivative. Anybody see something nice here? The 1/2 kills both 2, so you just get 1 plus x times y, and when you solve this for y, you just plug that shit there. Then you have an equation for the area, and then I can take its derivative, set it equal to 0. Is that cool? So again, I need you to understand, the broad outline of an optimization problem is set up the function they want you to maximize or minimize, take its derivative, get the critical numbers, make sure that they do what it wants to do. That's the broad outline. The first step, set up the function, that is the entire problem, basically. Setting up the function is always going to be the hardest part. It just is. And I can't break that down and say every time you do this and then you do this every single time. No, it depends on what's going on. Yeah. Well, the area for the Chapman formula needs what? It needs y.
Yeah, but if you change it to a squared and then.
Ah, sweet. Okay. I didn't want to say this, but yes, you could. All right. Let me see. Let's go on that extra little step. Does everybody agree that if I maximize the squared area of an object, I have maximized the area? So this is next level shit right now. But what sucks about solving this for y? It's going to involve me taking a square root. So what Peyton is saying, there's a little tear, is if I just square this damn formula, that's y squared. And y squared is 1 minus x squared. And then I can take a derivative. Beautiful. Do y'all agree with me right now? This is this, yes? And if I solve this for y, it's going to have a big x square root. The derivative is going to be product rule with a chain rule with a root. Can you guys foresee that happening? What Peyton said is, if you just square everything, then what do I need right here is y squared. That's what I would do. But again, you don't have to do this. But can anyone see how that makes this much nicer? Do you always want to do this kind of thing? No. So that's the trouble with me talking about this, because then students try to do it everywhere, and it's going to mostly make things suck. Sometimes it's going to make things better. Okay, maybe. Okay. Alright, that's enough. We gotta do this quiz. So, there are literally 2 problems on the quiz.
He gave it, he gave us. You know what I mean?
Okay.
Thanks for your time, Dan.